In this video, we have this question we're going to solve. The question is actually JAMB Mathematics. Alright, JAMB Maths from 2013. Question number 22. A very funny question, right? Now, following from what I explained in our previous videos when I introduced matrices, things you should know about matrices, because you can see that this question is a 1 plus 1 question. It's something you can really play around with. Now I'm going to be fast in solving it because this is really not something that should shake us. Okay? Now we are given this matrices P and Q, and the question says we should find 2P plus Q, simply 2 times P plus Q. Remember, this is a number. You're using to multiply P. So how do we go around this? It's very simple. We have P here. So 2P is simply going to be 2 times the matrix P, which is going to be 2. The matrix is 5, 3, and then 2, 1. So if you work in this, let's multiply and see. Whenever you're using a number to multiply a matrix, that number will refer to it as a scalar. The scalar will multiply each element of the matrix. So this is a 2 by 2 matrix that has 4 elements in it, So 2 times 5 is going to give us 10. 2 times 3 will give us 6. 2 times 2 will give us 4. 2 times 1 will give us 2. So this is the new matrix obtained, which is 2P. The question says we should obtain 2P plus Q. So 2P plus Q will now be the matrix called 2P matrix and then added to the matrix Q. Let's do that and see. Alright, 2P is 10, 6, 4, and 2. We are now adding it to the matrix Q. The matrix Q is 4, 2, 3, 5. So that's going to be 4, 2, 3, and what? 5. Okay, so from here we are now going to add up this matrix. So let us add up these matrices and see what we're going to get. How do you add matrix? From our previous video, I already explained all of this: addition, subtraction, and multiplication of matrices. For us to add these matrices, we are going to pick them corresponding elements to corresponding elements. What do I mean by that? Come to the first matrix. Now, the element in row 1, column 1 of this matrix, add it to element in row 1, column 1 of this matrix. Hey, before I even move on, I hope you know these two matrices can be added. The addition is possible because the order of this matrix is the same as the order of this matrix. I'm trying to take your mind back to the principles we established already. So we can actually add this because their orders are what? The same. Alright, let us go. Element in row 1, column 1 of this matrix is 10. Added to element in row 1, column 1 of this matrix. I will show the work in here. Is that okay? Which, of course, if you find yourself in example in this, you don't need to stress yourself. You could actually even come here straight on and get your result. 2 times 5, 10. Add the 10 to this 4, you get 14. So it's just a simple mathematics. So we're going to do 10 plus 4. So this will give us 10 plus 4, elements in row 1, column 1. And then we would shift our hand, element in row 1, column 2, added to element in row 1, column 2 of this, which is 6. Okay, I'm going to use black marker for that. So we separate the elements in different rows and column. Okay, then we move on to the next. This will now take us to element in row 2, column 1. Okay, we're going to add it to element in row 2, column 1 here. That's 4 and 3. So I have 4 plus 3. And then we take element in row 2, column 2 of this first, add to element in row 2, column 2 of the second matrix. That is 2 plus 5. Good. All we now need to do is just to do our addition. Come to this term. If you add, okay, let me conclude therefore 2P plus Q is equal to 10 plus 4 will give us 14. 6 plus 2 would give us 8. 4 plus 3 is equal to 7. 2 plus 5 is equal to 7. And so this is the result, 14, 8, 7, 7. This is the JAMB maths. Very funny, right? Okay, now what's the answer here? We are checking for that, which is 14, 8, 7, 7. So let's see. 14, 8, 7, 7. And that goes with option C. So option C is the correct option. Option C. So you can see how we handle addition, very simple. Take note what this scalar did. Anytime you're using scalar to multiply, that scalar number will multiply each of the elements of the matrix. The same thing goes with division. I said that in a previous video. you can use a scalar to divide elements of a matrix. Next in this video, we've got another question, still JAMB Mathematics 2020, that's the year, question 30. Now the question said if P is equal to 1 minus 2, 3, 4, and Q equals minus 2, 3, 1, 0, find PQ. To find PQ simply means obtain P times Q. Now matrix P has been given to us. This is a 2 by 2, so a square matrix. And then matrix Q has also been given to us, a 2 by 2 square matrix. Now we've explained how we actually carry out multiplication of matrices, and hence we're going to use that knowledge to solve this question. It's actually a simple one, something you play with without wasting time. Remember the principle, the rule. Pick rows from the first matrix using to multiply the columns of the second matrix. So let us do that and see. Alright? And once you solve that, following the principles that I have already laid out and how we handle this, you just see your answers smiling at you. So we go. We have to obtain PQ. PQ simply means matrix P times matrix Q. That's 1 minus 2 and then 3, 4. I'm going to multiply by matrix Q, which is minus 2, 3, 1, and 0. Before I even go into multiplying this, let me ask you, based on our previous knowledge, alright, from what I explained in the previous videos, can you multiply these two matrices? If yes, why? Okay? Of course, we can multiply this. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. For matrices to be multiplied, the number of columns of the first matrix must be equal to the number of rows of the second matrix. How many columns do we have here? 2 columns, this and this. How many rows do we have? 2 rows along the horizontal. So you can actually multiply this matrix. And we expect the result we are going to get, the order of that result is going to be number of rows from here, which is 2. And then number of columns from here, which is 2 as well too. So we'll still get a 2 by 2 square matrix as our answer. Anyway, that's not our interest here. Let's solve this and see. We want to proceed in multiplication. Remember, I've already laid out the pattern. We're going to use this first row to multiply column 1 and column 2 of this. So let's use it against column 1 first. So that's going to give us, I'll draw this. Are you ready? So row 1 times column 1. And if you are doing the multiplication, first element of row 1 in the first matrix times first element of row 1 in the column of the second matrix. So we're going to have 1 times minus 2. 1 times, for maybe they use blue marker for the elements in the second matrix. Now you're not done. What you did is row 1 against this column 1, which is 1 times this one. You will still move on the second element times this second element. That you are going to add up to this plus, so we go minus 2. Minus 2 from the first element, from the first matrix rather, the row of this times this one here. So this is what you're going to get. When you solve this, you will get the element that is going to occupy row 1, column 1. Because the multiplication you did here is row 1 times column 1. Now let us shift our hand a bit and then go ahead to do row 1 times column 2. I'm taking my time to explain this because we really don't even need to show all this working. We can just go straight on 1 times minus 2 plus minus 2 times 1. We move on again, 1 times 3 plus minus 2 times 0. And you're just getting your answer straight on like that. Okay, so 1 times the first element here along this row times the first element down this column. 1 times 3. So 1 times, you can use blue marker for that, the second element. Then I will add this to minus 2 times the second element here, which is 0. Good. Which is 0. You see? That's what we do. It means we are not going to be fast in doing for the second row here. The first row has done its work. So we go for the second row. It's going to be this row times this column, this row times this column. So let's go. First element from here times this. We're going to have 3 times minus 2. Minus 2. So I will add it to, I'm using the second element of this row to multiply the second element of this column now, which is going to be 4 times this 1. Okay, we are moving on. Times 1. 4 times 1. This is not 7. Take notes. It's 1. And then we now use this row again to multiply this second column. So we go. First element of this row times first element in the column here. So you get 3 times 3. So have this. I will now add it. Plus 4. The second element now will go to this second element. 4 times 0. 4 times 0. Good. All we now need to do is to work out this. Solve this whole thing, solve this whole thing, solve this, solve this. This is going to give you one whole thing here will give you the same one number. Then this one, work them together. So that's just all you need to do. Therefore, PQ is equal to 1 times minus 2 is going to give us what? Minus 2. So let me put that minus 2, add it to, this is minus 2 times 1, which is also going to give us minus 2. This plus times minus is minus. So we're going to have minus 2. This one gave us minus 2. This one gave us minus 2. Plus times this minus is minus. Then I'll come over to this. 1 times 3 is 3. I'm going to add it to minus 2 times 0 is 0. So it's going to be plus 0. Do same here. 3 times minus 2 is minus 6. Add it to plus 4. 4 times 1. Come here, do same. 3 times 3 is 9. Plus 4 times 0 is 0. And so PQ is simply equal to, work out this, you're going to get minus 4. This is going to give us 3. This will give us minus 2. And this is going to give us 9. Correct. We've obtained our result. So we can actually check for the correct option here. We have minus 4, 3, minus 2, 9. So minus 4, right? Minus 4, 3, minus 2, 9. The correct option is option D. You write it out here. Option D. So you see that's how simple this matrix, operation matrix they are. There's nothing difficult about that. I've taken my time to show you all the working. In subsequent videos, we're just going to play around that. No need of showing all the workings as we move on. We have successfully solved questions on addition and multiplication of matrices. We've got this question here again, still JAMB Mathematics, 2006, question number 31. The question said that if x is equal to 1012 minus 10 minus 101 and y is equal to minus 112, 0 minus 1 minus 1, 2 minus 1, 1. Find 2x minus y. 2x minus y is a simple problem. To obtain 2x minus y, we are going to simply multiply the matrix x by the scalar, by the number 2. And you know how to do that. In the first question, we already saw something like that where we used 2 to multiply all the elements of the matrix. Then we're not going to subtract y from it. And that's all. So you say this is actually very simple. I think I'm going to do that straight on. So we are asked to find 2x minus y. This is going to be 2 brackets. Now, the matrix x is what? We'll fix that 101. So 101. And then we have 2 minus 2 minus 1 and then 0. And we also have minus 101. So minus 1, 0, and 1. So we're going to subtract matrix y from it. What's the matrix y? Look at it. Minus 1, 1, 2. So we have minus 1, 1, 2. And then the next, second row is 0, minus 1, minus 1. So I have 0, minus 1, minus 1. And then the last row, which is the third row, is 2 minus 1, 1. 2 minus 1 and 1. So how do we do the subtraction? It's a simple one. We're going to use 2 to multiply all these terms here. Or should I do that for you to see it fully? Or should we just solve direct on? Okay, if you are seated for maths, you don't need to, for JAMB maths, you don't need to show the working like 2 times this will give you 2, 2 times 0 will give you 0, 2 times 1 will give you 2. Write the result you get there before subtracting this. It's going to be a waste of time. So let me just take you just one step on. We have 2x minus y is equal to, now we go. 2x means 2 times the element in x, then minus what you have in y. And you know, when doing addition and subtraction, you take it corresponding elements to corresponding elements. That is, the element in row 1, column 1 of the first matrix minus element in row 1, column 1 of the second matrix. So let us go. 2 times 2 will give us 2 times 1 rather. 2 times 1 will give us what? 2. Then 2, that 2 now is element in row 1, column 1, you know that. So that 2 minus this element, because this element is in row 1, column 1. Good. Minus will give us plus. So that definitely means that this will now be 2 plus 1. And 2 plus 1 is going to give us 3. So I'll fix 3 in row 1, column 1 of the answer I'm getting. We move on to row 1, column 2, together with this row 1, column 2. So first we're going to do 2 times 0, we get 0. Then 0 minus 1. 0 minus 1 is going to give us minus 1. So I will fix it in row 1, column 2 of my answer. We are now moving on to row 1, column 3. So let's work it out and see. 2 times 1 will give us 2. Minus the element in row 1, column 3 there, which is 2 here. And that's going to give us 2 minus 2. And 2 minus 2 is 0. So I'm done with row 1. Okay? Let's now move on to row 2. We do the same thing. So let me speed up. Okay? Because of time. 2 times 2 is going to give us 4. 4 minus the element in row 2, column 1 here, which is 0. So I have 4 minus 0 give us 4. Then 2 times this element minus 1, you're going to get minus 2. Minus 2 will now become the element in row 2, column 2. So it's going to be minus the element in row 2, column 2 of the second matrix. Now look at this. Minus times minus will give us plus. So this is actually plus 1. So you're going to have minus 2 plus 1. And minus 2 plus 1 is going to give us minus 1. So you fix it where it's supposed to be, row 2, column 2. Next, 2 times 0 will give us 0. Then minus. You know, minus will give us plus. So 2 times 0, which is 0, will now be plus 1. And then 0 plus 1 will give us 1. Let's go to the last row, row 3. 2 times minus 1 will give us minus 2. Minus 2 minus the element in row 3, column 1, because they are corresponding elements. They occupy the same position. So minus 2 minus this 2. Minus 2 minus 2 is minus 4. So you fix up minus 4 there. 2 times 0 is 0. 0 minus will change to plus. So you're going to have 0 plus 1, which will give us 1. 2 times 1 will give us 2. 2 minus 1 will give us 1. And so that's the result. Let's see the correct answer there. 3 minus 1, 0. 4 minus 1, 1. 4 minus 4, 1, 1. So we go and see 3 minus 1, 0. 4, 1, we all know that's not the answer. So 3 minus 1, 0. 4 minus 3, no, that's not the answer. 3, 1, this is not the answer. 3 minus 1, 0, yes. 4 minus 1, 1, yes. Minus 4, 1, 1, correct. So this is the correct option. Let me write it out here. Option D is the correct answer. So now we are done with operations on matrices, addition, subtraction, and multiplication. In our next class, we are going to look at equality of matrices. We're going to look at how to obtain determinants of matrices and a lot more other things like singular matrix, of course, transpose of a matrix, matrix of minor, matrix of cofactor, and how to obtain the inverse of a matrix. If you like what the GMAS 41 is doing through this, the GMAS 41 Support Student Education Initiative Program, please contact us to get enrolled. This program is free of charge. And we cover a whole lot of work, WIRED, JAMB, alright, entrance exams into higher institution, and the rest. Remember, the program is without charge. All you are required at the end of the month is to support this program with whatever amount you deem fit. No one calls you, alright, to do that. Take note of that. And of course, you can follow us on our YouTube channel. Please like our YouTube channel and then subscribe as well. Remember to turn on the notification bell so that whenever we upload any new video, you will get personalized notification. Thank you, and I hope to see you in our next class.